The Order of Time, Carlo Rovelli. Thousands of years ago, St. Augustine asked himself what time was. If nobody asks me, he realized, I feel like I know. But if I were desirous to explain it to one that should ask me, plainly, I do not know. Italian theoretical physicist Carlo Rovelli doesn't have this problem. Not only does he know more about time than almost anyone on this planet, but he is, arguably, one of history's most exceptional communicators of complex and counterintuitive scientific concepts. In his 200-page wonder of a book, The Order of Time, he simultaneously annihilates our common-sense understanding of time and elucidates its true, utterly baffling nature, and does so in a dizzying, poetic manner. Get ready to join him in a quest to solve nature's greatest and most profound mystery. The crumbling of time. Reality is often very different from what it seems. For example, the Earth is spherical, and yet it appears to be flat. Moreover, it spins around the sun, even though it seems the other way around. That being said, nothing works quite as counterintuitively as time. As physicists discovered only recently, that is, at the beginning of the 20th century, as much as time appears to be a uniform, universally flowing thing, it is, in fact, anything but. To use an analogy, time isn't really a river, and we don't inhabit fish swimming in the water. Rather, time is only one part of the dual, all-permeating fabric of the universe, woven together with space. Even more fascinatingly, though this space-time fabric is ostensibly smooth and continuous, it gets deformed by the presence of matter and energy. Hence, not only does time not flow, it also exists differently for different observers, depending on where they are and how much the space-time fabric around them is deformed. We conventionally think of time as something simple and fundamental that flows uniformly, independently from everything else, from the past to the future, measured by clocks and watches, writes Rovelli. In the course of time, the events of the universe succeed each other in an orderly way, past, presents, futures. The past is fixed, the future open. And yet, all of this has turned out to be false. One after another, the characteristic features of time prove to be approximations, mistakes determined by our perspective, just like the flatness of the Earth or the revolving of the sun. However, it is relatively easy to understand the spherical form of our planet and the laws of our solar system. It is extremely difficult to understand time, however. In fact, the more modern physicists learned about it, the less it made sense to them. Rovelli compares this progress to holding a snowflake in your hand. Gradually, as you study it, the snowflake melts between your fingers and vanishes. Pretty much the same thing happened with the concept of time in the 20th century. So, perhaps, St. Augustine was right after all. We understand time better when we don't try to understand it. Let's try to change that. Time is not uniform. Let's start with perhaps the most fundamental aspect of time, its unity. Time, we believe, passes everywhere at the very same speed. This is, however, completely wrong. Even if you place a clock on the table and compare it to another sitting on the floor, the two will differ slightly after a few decades. As infinitesimal this difference might be, it would still be factual and measurable. No matter what you do, a clock placed on the floor will always run a little more slowly than one on a table. The discrepancy has nothing to do with the clocks themselves. It has everything to do with the nature of time. As strange as it might sound, this is a simple and observable scientific fact. At a higher altitude, time passes faster than it does at sea level. If two friends separated today, with one of them choosing to live in the mountains and the other one remaining in the plains, the latter one would have both lived less and aged less if the two met a few years later. He would have spent less time to do things and think about things, and his clock would have oscillated a fewer number of times. And even though he would have probably never noticed, his plants would have grown less as well. Time moves faster in the mountains. This is one of the many things Albert Einstein discovered a century ago, that the flow of time is closely interrelated with gravitational forces. Namely, Einstein understood that gravity was a side effect of large bodies modifying the structure of the space-time fabric unfurled between them. Because of such modifications, light has to travel through more space around certain objects. However, since the speed of light must remain constant everywhere, time has to speed up to make up for the lost space. Earth, being such an enormous object, deforms the space-time fabric quite a bit, and, hence, slows down the flow of time around it. However, it does so at different rates. A valley is closer to its core than a mountain, for example, so time slows more at sea level than it does at higher altitudes. If things fall, it is due to this slowing down of time, writes Rovelli. Where time passes uniformly in interplanetary space, things do not fall. They float without falling. Here on the surface of our planet, on the other hand, the movement of things inclines naturally toward where time passes more slowly, as when we run down the beach into the sea, and the resistance of the water on our legs makes us fall headfirst into the waves. Things fall downward because, down there, time is slowed by the earth. Already mind-boggling? Well, wait till you hear the rest. Time doesn't have a direction. As far as our intuition is concerned, another fundamental aspect of time is its passage, its flow. Time, we feel, moves from the past to the future. There is always a before and an after. The effect comes after the cause. To quote Rovelli, pain comes after a wound, not before it. The glass shatters into 1,000 pieces, and the pieces do not reform into a glass. We cannot change the past. We can have regrets, remorse, memories. The future instead is uncertainty, desire, anxiety, open space, destiny, perhaps. We can live toward it, shape it, because it does not exist yet. Everything is still possible. Time is not a line with two equal directions. It is an arrow with different extremities. Strangely enough, this too isn't true. Believe it or not, in the elementary laws that describe the mechanics of the world, the difference between past and future doesn't really exist. Consequently, there is also no difference between cause and effect, between memory and hope, between regret and intention. They are all parts of the same fabric. Seen from different vantage points, effects and causes may become interchangeable, and the past can become the present. In fact, the only basic law of physics that distinguishes the past from the present and makes the arrow of time possible is the second law of thermodynamics. In the plainest words possible, it states that heat cannot pass from a cold body to a hot one. To make that even clearer, a cold cup of tea will never get warmer if left by itself. However, a hot cup of tea left by itself will always get colder. So far, so clear. But what does heat have to do with time? Well, pretty much everything. You see, a ball can rebound after hitting the ground, and a spring will come back to its original position after being extended. However, heat is irreversible. It never runs backward. If a sequence of events is allowed by Newton's rules of mechanics, Maxwell's equations for electricity and magnetism, or even Einstein's laws on relativistic gravity, then that same sequence is allowed to run backward in time by the same laws, not heat. The second law of thermodynamics states that entropy of a thermodynamic system can never decrease over time. It can only be produced, but never destroyed. As a result, the arrow of time appears only when there is heat. The link between time and heat is therefore fundamental, writes Rovelli. Every time a difference is manifested between the past and the future, heat is involved. In every sequence of events that becomes absurd if projected backward, there is something that is heating up. Yes, that includes the act of thinking itself. The sole reason why your thoughts can only move from the past to the future is because thinking produces heat in your head. Time doesn't have a definite present. A whole decade before realizing that time is slowed down by mass, Einstein understood something even stranger, that it was slowed down by speed. The consequence of this discovery for our basic intuitive perception of time is the most devastating of all, remarks Rovelli, because it means that the faster you are, the slower time moves for you. This utterly annihilates the idea of the present moment. As intuitively graspable as it might seem, the word now is pretty much meaningless in scientific terms. Even while you are watching the sunset, the sun has, in fact, already set. From its reference frame, you're pretty much stuck in the past, because it takes the light from the sun approximately 8 minutes and 19 seconds to reach Earth. That is precisely how far back into the past of the sun you're seeing at any of your apparent nows. Otherwise stated, the now of the sun and your now are two different moments of time. It is almost as if you and the sun exist in two parallel worlds. A famous thought experiment makes the paradox even more apparent. Let's just say that your sister has decided to leave Earth and start a life on the recently discovered planet Proxima b, located about 4 light years away from Earth. Now imagine you own a telescope that can see at least as far. What would you see through your telescope at any given moment? Well, that's easy. Your sister from 4 years ago. And that's because it takes light 4 years to reach your eyes from Proxima b. But this is where it gets much weirder. In your sister's world, your now is 4 years in the future. And 4 years is a lot of time. Provided humanity has developed sufficiently fast spaceships, she might even be able to return back to Earth in 4 years. In theory, this means that a certain now you might be able to both see your sister reading a book on Proxima b and entering your house on Earth. It simply makes no sense to ask which moment in the life of your sister on Proxima b corresponds to now, comments Rovelli. It is like asking which football team has won a basketball championship, how much money a swallow has earned, or how much a musical note weighs. There is no special moment on Proxima b that corresponds to what constitutes the present here and now, he concludes. Time isn't independent. It may sound like something out of a science fiction movie, but the Proxima b thought experiment is based in reality. It is an illustration of yet another scientific fact, namely, that now lasts differently at different places. Rovelli explains it thus. There is our past, all the events that happened before what we can witness now. There is our future, the events that will happen after the moment from which we can see the here and now. Between this past and this future, there is an interval that is neither past nor future and still has a duration. 15 minutes on Mars, 8 years on Proxima b, millions of years in the Andromeda Galaxy. It is the expanded present. The Proxima b experiment also shows that the faster you are, the slower time moves. In October 1971, two Americans, a physicist and an astronomer, sent 4 cesium atomic clocks on a trip around the world aboard 4 different commercial airliners. When they compared the clocks against the ones that remained at the U.S. Naval Observatory, they discovered discrepancies in line with the ones predicted by Einstein's theory of relativity. The experiment, in other words, provided definite proof that time indeed moves slower at higher speeds. However, since time also moves faster at higher altitudes, frequent flyers age more quickly than those of us on the ground, losing about 59 microseconds every 10 million miles traveled. The reason why time acts so weirdly is rather simple. It is not an independent aspect of our universe. As Einstein discovered, time is directly connected with something we are able to understand a bit better: space. Time and space are two sides of the same coin, two interwoven threads that form the fabric of the cosmos, the space-time continuum. When an object of massive size, such as the planet Earth, warps space-time, the result is gravity and a specific flow of time for that specific place, fully dependent on the size of the denture. The bigger the denture, the slower time moves. Black holes, for example, bend the space-time continuum so much that time stops moving completely inside them. So, not only is time not uniform, it is also not present everywhere. There are some places in the universe where, loosely speaking, time doesn't exist at all. The world is made of events, not things. Under the increasing scrutiny of 20th century physicists, time lost all of its traditional layers: uniformity, direction, independence, leaving us with an empty, windswept landscape almost devoid of all trace of temporality. And yet, that is precisely the world we live in. One of the strangest consequences of this line of thinking is the following: nothing ever is, everything, ultimately and merely, just happens. At first sight, there is a big difference between a stone and a kiss. While a stone lasts, a kiss is temporary. The former is the prototypal thing, the latter an archetypal event. Where would a rolling stone end up 12 seconds after being kicked by a boy on a beach is a perfectly legitimate question. However, one would never ask a friend where their kiss might be tomorrow, lest they want to be considered eccentric. Instead, they would ask something like, when did you have your first kiss? Where is for things because they exist in space. When for events because they exist in time. But as we just explained, time and space are not separate from each other. They work together. And, indeed, upon closer inspection, we realize that even the most thing-like things in the world, such as stones, are nothing more than very long events. The hardest stone, writes Rovelli, in the light of what we have learned from chemistry, from physics, from mineralogy, from geology, from psychology, is in reality a complex vibration of quantum fields, a momentary interaction of forces, a process that for a brief moment manages to keep its shape, to hold itself in equilibrium before disintegrating again into dust. True, a stone lasts much, much longer than a kiss, but looking from afar, that's the only difference between the two. Both the stone and the kiss have a beginning and an end. Everything that exists in space does. Hence, everything is a process. Thinking of the world as a collection of events, of processes, Rovelli comments, is the way that allows us to better grasp, comprehend, and describe it. It is the only way that is compatible with relativity. The world is not a collection of things, it is a collection of events. The inadequacy of grammar. The popular Netflix German TV show Dark is introduced by a quote attributed to Einstein. It states, "People like us who believe in physics know that the distinction between past, present, and future is only a stubbornly persistent illusion. This isn't really a metaphor. It's something more than that. Sometimes time is complicated because language is too simple to speak about it. Our grammar is inadequate." Einstein's quote is taken from a letter he sent, near the end of his life, to the son and sister of Swiss engineer and friend Michel Bessot, after his death in March 1955. It is notable not only because it comes from his hand, but also because it implies an important distinction between two age-old philosophical concepts, presentism and eternalism. Let's further break down the distinction. Presentism is the idea that only the present is real, that the past and the future are not, and that reality evolves from one present to another, successive one. That is how we looked at the world before Einstein. We knew precisely what now meant because we believed in the existence of an objectively observable universal present. What Einstein most strikingly discovered was that any now made sense only in relation to an observer. The corollary is not only that what is present for one person is the past for another, but also that what is real in one frame of reference is not actually real in another. That's the position taken upon by eternalism, the idea that flow and change are illusory, and that present, past, and future are all equally real and equally existent. This view is much closer to the truth. However, not even that view represents the whole truth. But then again, almost nothing does. True, our world is described well by presentism. We know for a fact that there is no order of time. However, the distinction between past, present, and future mentioned by Einstein in his letter, in the strict sense of the word, isn't illusory. The three just don't follow a universal, global, objective order. Even so, the actual fact that the present of my sister on Proxima b is located in my future here on Earth doesn't change anything about the conditions of either of us. Both of us can experience time only where we are. The perspectives are mutually incommunicable. Perspective and time. Even though time works nothing like how we perceive it, our intuitive perceptions about it must have come from somewhere. Our ancestors thought wrongly that the sun revolves around the earth, and not vice versa. But we can easily understand why. Sunrises and sunsets. So, where does our faulty intuitive understanding of time come from? And how wrong it really is in relation to us? In a world without time, observes Rovelli, there must still be something that gives rise to the time that we are accustomed to, with its order, with its past that is different from the future, with its smooth flowing. Somehow, our time must emerge around us, at least for us and at our scale. But how? Imagine for a second a group of children deciding between themselves the two opposing sides in a football game by, say, tossing a coin. Of course, after some time, there would be two teams of equal size running around the field and trying to emerge victorious. Rovelli's thought-provoking question is not who wins, but rather, where were the teams before the coin toss? The answer is, of course, nowhere. Simply put, neither team existed. They are both the direct result of the coin tosses. They are both emergent phenomena. Time is pretty much the same. It is not an objective fact. It is not something that exists out there. Rather, it is something that emerges because of our particular perspective of the universe, which, in turn, owes a lot to a specific set of circumstances. In our universe, for example, entropy always increases. If it were the other way around, we would have lived in a world not unlike a movie being rewound. As captured in several scenes of the beautiful 2009 movie, Mr. Nobody, in such a world, pieces of shattered glass would habitually form bottles and thin strings of smoke would haphazardly shape into perfect cigarettes. As Rovelli concludes, the entire difference between past and future may be attributed solely to the fact that entropy of the world was low in the past. Entropy and time. Time exists because of entropy. In the absence of entropy, that is to say, if nothing ever changed, there would be no time as well. So, in a way, it is entropy and not energy that drives the world forward. Without low entropy, writes Rovelli, energy would dilute into uniform heat, and the world would go to sleep in a state of thermal equilibrium. There would no longer be any distinction between past and future, and nothing would happen. We don't know precisely why, but, for some reason, we are living in a universe and inhabiting a certain part of it, where the second law of thermodynamics works to our benefit, rather than to our detriment. It all starts with the sun, a rich source of low entropy. The sun radiates hot photons, light particles, into the direction of the Earth, and the Earth harks back by emitting 10 colder photons. The energy of one hot photon is more or less equal to the energy of 10 cold ones. So, the energy that enters the Earth is pretty much equal to the energy that exists. One hot photon, however, has less entropy than 10 cold photons, because the number of configurations of a single hot photon is lower than the number of configurations of 10 cold photons. That is because, as we already mentioned, heat always moves from hot to cold, and not the other way around. Consequently, the Earth can use the sun's energy to power its processes and to make things move around, rather than vice versa. Low entropy subsequently transforms into high entropy. That is precisely what happens inside one's body. That's what breathing, eating, and having sex does. These processes will ultimately result in a state of higher entropy called death. But even that state, the final one for a human being, will have lower entropy than the following states, which we refer to as decomposition. The truth is that everything around us disintegrates in one way or another. Time is, in many ways, the recording of this disintegration. The great story of the cosmos, everything from evolution to history, is powered by the growth of entropy. The scent of the Madeleine. We are processes, events, composite, and limited in space and time, writes Rovelli. But if we are not an individual entity, he goes on, what is it that founds our identity and its unity? What makes it so that I am Carlo, and that my hair and my nails and my feet are considered part of me, as well as my anger, my dreams, and that I consider myself to be the same Carlo as yesterday, the same as tomorrow, the one who thinks, suffers, and perceives? The answer is numerous different ingredients, but Rovelli highlights the following three as the most interesting and significant ones. Point of view. Everyone identifies with a certain point of view. That is the first ingredient of our identity. The world is reflected in each one of us through a rich spectrum of correlations essential for our survival, Rovelli explains beautifully. Each of us is a complex process that reflects the world and elaborates the information we receive in a way that is strictly integrated. Organization. The second ingredient is organization. Both individually and as collectives, we tend to group and segment things into entities so that we can better understand and grasp them. That is the only reason why we call a certain collection of rocks and fields Mount Everest, and a specific assembly of ever-changing atoms and cells Jack or Jill. In reality, all three of them are events, limited in space and time. We limit them further so that we can talk about them. Memory. The third and final ingredient of our identity is memory. As far as time is concerned, this one is perhaps the most essential ingredient. It is memory, and not something else, that catalogs the numerous processes of the world into a narrative that lives inside our brains, making strict distinctions between past and future events. People with memory disorders can't do this. That's why they have ever-changing points of view and issues organizing the world in a neat manner. Furthermore, that's why they regularly confuse the past and the present. Without a properly working memory, we stop existing as unified beings. Nothing guarantees our identity more than our memory. Final notes. The Order of Time has been described as a pocket-sized guide to unraveling the mysteries of time, and as a deep and remarkably readable dive into the fundamental nature of time. Neither of these descriptions is an exaggeration. On the contrary, they may both be understatements. Mind-bending, in the opinion of Michael Pollan, compact, according to Nature magazine, and highly elusive and dizzyingly poetic for one Guardian reviewer, The Order of Time, in our humble opinion, is the best book on this fascinating subject ever written. Highly, highly recommended.
Hi, I'm Rhonda, and this is an exclusive audiobook video recorded for the Audiobook Master channel. Enjoy your audiobook and have fun learning. Don't forget to subscribe and hit the notification button so you'll get updated on our next upload. If you liked the video, give us a thumbs up and say your thoughts about the book we just covered. Do you want to listen to a summary or review of a book that we haven't covered in the past? Say it in the comments below or send us a message. Don't forget to check our other uploads. Enjoy listening!